and welcome back to the seminar for Alberta Geotechnical Center. And today we are very delighted to have Mahamood in our for our session. His topic will be about the overview of the Canadian Dam Association's technical bulletin of the Tailings Dam Breach Analysis. And just a little bit the housekeeping rules for the attendees. First, keep your mics muted so everyone can hear the presenter. And second, the Q&A will happen after presentation. Please ask questions by using the chat function. You can either send it to everyone so others can see which questions have been asked, or send privately to the host, or who will post your questions to the group on your behalf. And the moderator will be me today. I will choose which questions to ask the presenter. And if your questions isn't answered, please take the initiative to follow up with the presenter via email. And third, these sessions will be recorded. So if you don't want to have your image in the recording, please turn off your camera. And here is just a short bio for Mr. Mahamood. He has 20 years of experience in geotechnical, geoenvironmental, and infrastructure engineering, and led multidisciplinary, multi-stakeholder teams that delivered complex and challenging design and construction projects. His areas of expertise include design and construction of embankments, dams, and waste dumps, dam safety management, including water, hydropower, mining, QA and QC, preparation of construction and specification, regulatory compliance, risk management, tailing management, large site investigation, and foundation characterization programs, including laboratory and in-situ testing and construction management. And Mahamood currently leads the Prairie Dam Engineering Group for Tetra Canada. He leads project delivery and proposal preparation for various infrastructure, dam safety, irrigation, water management, and mining projects. Managers and also mentors technical staff and participates and contributes in business development and strategic planning. He receives his Bachelor in Civil Engineering from Bangladesh University of Engineering and Technology, and Master in Geotechnical Engineering from University of Calgary. And Mahamood is also an active member of the Canadian Dam Association. He chaired technical committees, workshops, organized several workshops and conferences for CDA and TMW, which is the Tailing and Mine Waste, and the Canadian Geotechnical Society. And without further ado, let's welcome our guest, Mahamood. Floor is yours.
All right, thanks, Bo. Thanks for the introduction. Hi, everyone. So I'm going to give you guys an overview, and then going to touch into some of the highlights steps on the recently published Canadian Dam Association's bulletin on the Tailings Dam Breach Analysis. And the presentation that I am going to give, it was originally prepared by my colleague at the Tailings Dam Breach Working Group, Dr. Violeta Martin and Dr. Mohsini, and also being contributed by other members, active members of that working group. So I wanted to acknowledge their contribution before I get into the bits of the presentation. So in terms of the presentation outline, I know that we have some grad students in the mix. So they are organizing these. Thanks for them to allow me to make this presentation. So I added a couple of slides at the beginning just to go over basics of the tailings dam and tailings dam breach, just to familiarize with this topic, and why I think the need for this bulletin was felt by the community, and why we put this effort to prepare this bulletin. And then I'm going to spend some time talking about the organization of the guideline and the process flow diagram that we have in the bulletin, and how the whole bulletin is organized. And then this will be followed by some of the highlights of the key steps. I don't intend to go through the minute detail of the different steps and topics that we have covered in the bulletin, but I will touch base some of the important items which I think is going to be valuable for the attendees and also provide some clarification. And finally, I think although the working group has completed this bulletin, we are not done. We are still trying to stay together and do more in terms of promoting this particular topic on the bulletin. So we'll talk about that a bit, time permitting. So what is tailings dam? I think most of you guys are probably familiar with that, but those of us that are not quite familiar with this terminology. So when you say tailings dam, we actually mean like it's a containment or it's a barrier structure that are usually constructed in the mining operations to store their mining byproduct, which is tailings, which and then and basically we can see those two, the material that are being deposited behind this tailings dam are as tailings and the supernatant pond. And as you can see on the right side of the slide that there are different ways of constructing these dams, popularly known as upstream method, centerline method, downstream method, depending on how they have been constructed. And on the side that I'm showing an image of the Fundão tailings dam in Brazil, which I will make some reference to that in some of my upcoming slides. So what is the dam breach, and then why, tailings dam breach needs more attention with respect to the conventional dam breach that we have been familiar with, the water dam. Now, this is an example. I just put it side by side. One on the recently there was a breach on the Edenville Dam in Michigan in 2000. I just picked up a typical cross section of a water dam, and you can see that this trapezoidal dam that is holding the reservoir. And if that dam fails, basically it unleashes the rush of water, right? So the downstream, you can see all the water gushing and inundating the downstream. But likewise, if you look on the right side, and if you start looking from the bottom of that right side, you can see this is a cross section of a tailings dam, something similar to what I have shown in the previous slide, but it has more details. I just took it from the Fundão Dam, the expert panel report, and it shows the cross section of the dam, and it's holding fine tailings and slimes and coarse tailings. So this kind of material. And then once it breached, you will definitely see the material will come out. So as you can see the side-by-side comparison, that tailings dam breach and post-breach characteristics are not like similar to the water dam breach. So it does need some particular attention. So with that, I want to also elaborate a little bit on that. Like, this is a typical tailings storage facility, as I said, just another schematics. You have the dam, you have the tailings, and you have the supernatant pond. Now, in terms of understanding how the tailings dam breach works, I just draw these schematics on 3 circles. And that's how I actually see this whole thing in terms of doing a dam breach study. You can see my green circle, or oval, which is basically the post-breach. This is where the tailings was all being retained. And then the second one, the black circle, is the dam, right? So how the dam has the breach occurred. And then the third part would be once the breach occurs, how the material is going to flow in the downstream. So as you can see that, unlike water dam, you will need to understand first of all, the geotechnical characteristics of these tailings, and then the hydrotechnical characteristics of these tailings in terms of when they are going to flow. So it's a complex process, and it goes beyond one discipline of engineering. It needs to be brought in the knowledges from multiple disciplines that are involved into the tailings dam design, construction, and operation. So that's kind of the breakdown of how complex this breach could be. And with that, why we need to worry about, dam breach, tailings dam breach, particularly in terms of, and then understand the after effect of the tailings dam breach, because this is something very important in terms of understanding the dam consequence classification, emergency planning, mitigation planning, right? So it's important that we at least come up with a realistic and acceptable and reasonable inundation map, so that uh, the subsequent work that is going to be done, like as I say, consequence classification, emergency planning, or mitigation planning, can be based on those plans. And that's why I think we need to be more mindful about doing this study. And I think the other um, aspect that I think would also be quite clear by now, that what happens in the tailings, which is a give or take like a tailings slurry, it could be in a slurry form. And geotechnically speaking, if this material, it's a solid material with water, if it liquefies, then I think the aftermath of a tailings dam breach will be more significant compared to if this material doesn't liquefy. And then we also understand that if there is a supernatant pond or water on the tailings pond, that will have a profound impact on the post-breach characteristics of that particular facility. So with all these things, we understanding, and then we consider that a process should be developed that considers both hydrodynamic and geotechnical processes. And with all these, I think we started to feel that we need to develop some guidance document. So a little bit of history with respect to how CDA gets involved. Back in before 2014, I think there wasn't really much in terms of concerted effort to come up with any guidance document. I mean, I started my practice in early 2000s, and I know that at that time we're using the water dam based modeling, and we started to fill the gap and the issues around how the challenges we're facing, that why that approaches were not adequately capturing the tailings dam breach phenomena. So in 2014 and 2015, we actually did a workshop, series of workshops. First workshop in 2014, we did a state of practice workshop. We invited people from Canada, North America, and also internationally, to share their knowledge, like how they are doing, what kind of approaches they're using, what kind of challenges they're having. So that was a day and a half workshop, very successful, attended by a lot of interested parties. And then that followed another workshop where we wanted to see actually how we can coordinate our effort. And following 2015, Canadian Dam Association Mining Dam Committee mandated a working group and said that, okay, let's try to develop a guideline document on that. And that working group worked 2016 and still working, I think. By 2020, we had the final draft. And in between 2017 and 2019, we had a couple of workshops where we gathered input from the interested parties. And finally, late last year, I think the bulletin came to light. And so this is how it looks, the cover, and it's now available in the CDA website and available for purchase. So in a broad brush, I think it's a document that has 13 sections. First two sections, we talk about some of the basic stuffs, and then the rest of the sections, we try to capture, the processes that we think is appropriate for such a study. And you will be hearing me saying the word TDBA, which is just a, we engineers like to come up with short terms. So it's a tailings dam breach analysis. So in the subsequent slide, there will be a lot of reference to this word. So when you say TDBA, we are actually referring to tailings dam breach analysis just in a short form. So this is kind of the fundamental construct of the bulletin. And as I said that, we engineers, we like to go step by step. So when we put this bulletin, I think we also try to come up with a process like that. So the idea of the bulletin was always to capture what need to be done, not so much how it should be done, because it's an evolving field, and there are ways, more than one ways to do certain things. So that's why we did not want to go into too much into which software you should use, which methodology you should use. Rather than our focus was that we come up with a reasonable framework so that for any given dam, tailings dam, you can take it and you can look it into the critically, and then you can come up with a process and make sure that you are not missing the key items that need to be considered and not forgotten in the process of tailings dam breach analysis. So, so that lead to this process. And then as you can see that the first step is of course the objective and scope, because that's important. Why you wanted to do a tailings dam breach study for a given dam? Do you want to do it for to just a preliminary understanding of the downstream impact, or you wanted to really do a detailed study so that you have a very high resolution map and inundation and that kind of stuff, right? Or you are at the very early stage of the project. So that will dictate the extent and scope of the study. So that has to be very clear at the outset. And then I think the important part is the background information review. Now we put a logic step there. The reason is that we have seen, at least in my practice, and a lot of my colleagues will agree to that, a lot of the time we are asked to do such study, but we don't have all the required information. So what kind of information we need? We need to have a very good understanding of how the TSF is designed, right? What kind of design methodology, what material used, and how it is being constructed as much as we can. And then we need to understand the operation, if it is an operating facility, and the site condition. And then the third thing is the tailings characteristics. I'm going to touch on that a little bit in the subsequent slide. It's very important that we understand the tailings, because it's a tailings dam and tailings flow. So you have to have a good handle on that. And that might need some field and laboratory investigation. I think the idea is not that we are asking you to do a field and laboratory testing before you undertake that. In most cases, in most of the well-managed operations, you will already have this information as a part of your geotechnical or your process, the tailings processing study and all these things. A lot of this information should be available. And then the other aspect of this, the liquefaction potential of the tailings, that's very important, because we need to know whether the tailings as a solid is going to come out if the dam is being removed. So that's an important information. And then the topographic data, because the downstream topography is also going to have a profound impact on how the breach, subsequent post-breach scenario is going to develop. And then hydrologic data is important, because you need to know how much water is going to come from the hydrologic event. Now, the idea is that you go through you gather your information and you kind of come up with collectively as a team that, yes, we have the adequate information. So let's move on into the subsequent step. Now, the important part is that we know that in reality, you may not have all this information, and in some cases it might be okay. So if you make some assumptions around some of the missing information or the processes, you just make sure that everybody is on the same page, that these assumptions are made, and then that will be carried forward to do this study. And then I think, you will get into the subsequent steps. So beyond that, I think I will move into some of my slides. I think I'm going to talk about that. Yeah, so in terms of the study scope, a little bit more on that. Now, we know that, as I said, that the study scope, sometimes you may not need a very detailed study in terms of the breach analysis and inundation mapping or that kind of stuff, but you just need to understand the preliminary understanding of what's going to happen if the dam fails. So you may be able to do a desktop study, but you can still follow that framework up to a level that where you think that you don't need to go into further details. And then, of course, you can do the detailed study. The other also relevant question we get from time to time, the validity period of the TDBA, right? So we know that the tailings facility usually has its own life cycle, right? So if it transition from one stage, let's say construction, operation, to the closure and post-closure, so there will be material change on the facility. So you need to do update your inundation study. And then the other time you have to do it if there is a major changes, right? If there is a major change in the downstream, there is a new building or new settlement, so then you need to revisit your existing inundation study, or there is a changes to the design of the facility. You raise it by another 10 meters that wasn't anticipated. So it's just a common sense, right? So we are trying to understand using this study to capture the downstream consequence. So or the downstream impact. So if there is something happens either in the downstream or in the upstream, then you need to revisit your study and capture that. Now, the failure modes and dam failure scenarios. So this is very important for the tailings dam, and there have been multiple guidelines and best practice document has been published recently. So there are ongoing discussion around clarity of what kind of what should be explored in the tailings failure modes or critical failure mode, or that, so on and so forth. So what's important to understand from the dam breach perspective is that you cannot just pick and choose one failure or location and failure mode and go from there by any presumptions, right? So what we um, advocated in this bulletin is that you have to have a physically sensible and realistic failure scenario and the failure modes that you are going to use, not like a failure mode that you think has very remote possibility of being occurring. So we use the word critical and credible failure mechanism, but don't get too hung up on the the word credible failure mechanism, because we know that there are some different thoughts about the actual definition. But without getting into that, what we are saying, it has to be physically sensible and realistic, so that the prevailing failure mechanism or the failure modes, collapse or overtopping, the way the dam usually fails, that can be related. Now, all relevant TSF stages, including construction, operation, and closure. I think it's just tying with what I said, that if you are doing a facility that is going through, the different phases, then you need to put that into perspective as well. And the other part of this is that this is just another snapshot of the Mount Poly. It's in British Columbia. So you can see that it's a ring dike. It's an external tailings facility. I just randomly throw a bunch of arrows. What I mean by that, it could fail in any locations, right? I'm just, without knowing much detailed about the actual construct and the design of the dam. So the point I'm making is that you need to really look into your facility, how it's being constructed, and what are the constraints, and then draw as many lines, like all the potential breach locations, right? And then use a screening process. Like you start with your breach locations, look into your failure modes and failure scenarios, and combining those and critically looking into all those, you have to come up with, okay, so these are my physically sensible and realistic failure mode that is going to give us the most consequence. And then you carry those failure mode for the subsequent stages of your study. Now, before I move too further, I think I just wanted to add a little bit about the tailings characteristics. So composition and characteristics to evaluate whether tailings is susceptible to flow liquefaction. So we talked about, we mentioned about CPT and other in situ and laboratory testing, but I think the main point is that you have to understand how your tailings is going to behave if the tailings dam is no longer there. Is it going to kind of stay there as a solid mass, or is it going to run out as a fluid material? So how do you do that? I think there are ways in the geotechnical investigation and understanding process. I just put in a CPT trace. That's one way. It gives you the particle profile, and you can develop your general understanding of the tailings across the facility. So that could be one way. And then the other term I'm throwing here is the tailings rheology, because as I have shown in my previous sketches, that there are three bubbles, right? Your facility, your dam, and then your downstream, right? When the tailings started to flow downstream, and how it's going to flow, the flow behavior will depend on the rheology of the tailings. So that's some information that we also need to uh, be available to use for this study. All right, so if you remember the flow chart that we had, so this is one of the kind of the central part of the process. What we are saying is that if you have a tailings facility, and if you look at it, just look at it the way it is right now, and say whether it is holding water or it can hold water in the event of a big rainfall, right? So it's not a very difficult, you don't really need to do a lot of study. I mean, if you have a general topography and if you look at visually, you can get your head around that. So the big point is that water is close to the dam, right? If you have a large tailings facility and it is holding some water far away from the dam, then it may not be that critical. So when we say supernatant pond, we are referring to something similar to what you have shown in the sketch, right? It's close to the dam and it is available to come out in case of a breach. So do you have that? So that's your first logical question to ask. And then the second piece is a little bit loaded. Now you need to say, okay, is my tailings is liquefiable? So it's not an easy question to answer, especially for some of the facilities that hasn't been gone through a lot of rigorous investigation. But unfortunately, without knowing that, or at least having some understanding of that, you won't be able to do a proper inundation study, or whichever type of study you do, it's not going to be complete without understanding if that material is going to come out or not. So that's something we are capturing by asking the question, is it liquefiable or not? So as you can see that these are the two variables, and then there could be four combination of these, right? Yes, no, yes, no. So then we are saying, we're just referring them as we are engineers, lack of a better imagination. We just say case 1A, 1B, 2A, 2B. So 1A, 1B is basically surroundly around, you have a liquefiable tailings, and 2A, 2B, you don't have liquefiable tailings. Now this is, to bear in mind that it's just giving you a framework to articulate your thought process, and before you jump into very detailed analysis. It's not like for a given dam, you may have to use your judgment and understanding, and you may have to explore a little bit more to use this framework. So it's not going to be like, every dam is just the best available tool. In other words, it's not precise or straightforward, but at least it is something that will give you a starting point. Now, the another representation of the same process, we usually fondly call it our 2x2 matrix. It actually has a 2x2 form. So if you just take this, okay, is my tailings is liquefiable? Is there a supernatant pond? So I would ask you to pay attention to the words that we mentioned. We said that we didn't just say supernatant pond. We said supernatant pond present or pond release possible during breach. So that's the important part. Is the release is possible during the breach? If it does, then it's that's what we meant. And then whether your tailings is liquefiable, decide. So you can see that case 1A, you have liquefiable tailings with supernatant pond, and then the same scenario without pond in case 2A to B. Now, the other point I wanted to emphasize is that, I mean, those of you guys are familiar with the tailings, you are probably familiar with the term, liquefaction. Now, here we are particularly interested about the flow liquefaction that could be induced by any trigger, static, cyclic, or /seismic, including lateral unloading. So what we meant here is that if you have a liquefaction, not necessarily you say that liquefiable tailings, and of course it's fit into 1A, but what you need to understand and be confirmed is this flow liquefaction. In other words, what we are saying is that if this containment, if this trapezoid which is holding these tailings, for some reason, if a portion of this is gone, would this material will be come out as a flowable material, right? So that's kind of the main point. If that happens, then I think, yes, you need to consider that as a case 1A or 2A. So as I said, that these things are not quite straightforward, right? So there will be some judgment and some understanding that need to be considered around that. So what are those? So for example, if you have a case where you have a facility that has been closed, there is no water, So in a sunny day failure or normal case, you don't have any extra water. But if you have that same thing fails during a hydrologic flooding event, then it will become like a water holding facility. So then your 2A may come into 1A. The likewise, if you have a non-liquefiable tailings and no water, but then if you have a space within the crest of the facility that can actually hold water, and then if that causes failure, then you have to consider it as a case 1B, just as an example. So then I think we also looked into some of the case histories. Are these we did tested this 2x2 matrix or this framework, right? And here's an example, right? So we looked into the case histories, like for example some of the recent failures and also some of the historic failures. You can see that there's examples. I'm not going to go too detail about that right now. So then now the hard parts come. So once you kind of go over your facility, you understand your tailings, you come up with your 2x2 matrix and your mechanism. Now you need to do the actual breach analysis and then the modeling and so on and so forth. So now I say that as I said that, like you have to understand three parts, right? These three bubbles. The reason I'm saying overlapping, they are not like standalone because they are all going to be dependent on each other, right? So breach analysis is basically understanding the physical process of tailings breach, right, for a given facility and a given case, and then calculate the how much volume is going to come out, expected to come out, and then you have to understand how the dam itself is going to breach in that process. Once that two happens, then you got a big mass. And then third part is that you model the breach extent downstream. So those are basically three parts. So there is lots of detail in terms of these three steps. And as I said, that it's an evolving science. So we were cognizant of that when we developed this bulletin. But here I'm going to touch some of the aspect of it. The intent is not really go into the details of any of those. So the physical process of tailings dam breach, which is how the actually the breach will unfold. Like if you are in a case 1A, 1B, we are calling it, you'll have an erosional breaches because you have the supernatant pond, it will erode tailings when it being released. And so that's one part of your flow. And then if you have a liquefiable material, so that will come out. So that's your case 1A, 1B, kind of a general understanding of the process of breaching. But then if you have a case 2A, which doesn't have water, it's just that if the dam fails, it's just the liquefiable tailings, if there is a liquefiable material. But then if you look into case 2B, there is no liquefiable material. That means it's not going to flow. There is no water. So only, there will be a slumping or slide, right? For that kind, because there is no water. So that gives you a sense of how the breach will unfold. All right, so the what constitutes the outflow volume, right? So that's what we are saying here. Now, once you understand your physical processes, you will have one of these six elements in your total outflow volume. Either you will have a pond, like if there is a pond there, which you can estimate because you can do a bathymetry, or you can you know the supernatant pond, and then how much material is coming through the supernatant pond as an erosional process. So that will be the second element, irrespective of you have a liquefiable tailings or not. And then the third thing will come out is your liquefiable tailings, if the tailings is liquefiable. Now, even if the tailings is not liquefiable, because it's your containment is gone. So once you lost your pond, your tailings behind that will have to come to some sort of equilibrium, right? So you may expect some slumping behind that, even if there is no liquefaction happen. Because if liquefaction happens, then there will be lots of material come out. So either one or the other case will happen, right? And then depending on your how wide and how big the dam, your dam fill material will also come out. Now, if the dam is holding a lot of material, big pond and everything, which you see in many tailings facilities, then this material will be very, very small compared to the whole the total amount of the outflow volume. So, but give or take, these are the elements that you need to calculate and understand how much is going to happen. So this is one example how we think that we should look into the outflow volume calculation for the case 1A, where you have a supernatant pond, and then you lost your dam, let's say, and then your material will start to unfold, and then eventually it will be released, and then you will end up with a backscarp. And then in terms of the plan view, if it is a ring dike, then you will be seeing like a failure scar here, like what you have seen in the Meadow Street, right? So that's kind of the idea. And we talked about how you can use a simplified approach or more detailed approach. You can calculate that. All right. So the second part is my second bubble, right? The black part, the breach formation. Now that's a challenging element in a sense that even the breach formation of water dam with earth embankment is also not completely understood. Some of my hydrotechnical friend may or may not agree to that, but I think that's one observation by the working group, because we know that there are some established science on how to do the overtopping or piping type breach modeling, but they are not readily usable for the tailings dam. For the erosional type failure, you can use them with some modification, but where you have a liquefaction trigger, it would be difficult. So there are some discussion around that, and it's an evolving science. So there might be, you will have to go above and beyond in some cases if you wanted to fully capture that. And then you have to see the relevance of this with respect to the overall study for that. And then the next step is that breach outflow. Now, there are more than one ways to capture that. I think what we adopted in the bulletin is that the solid concentration, because what is going to come out, my third bubble, right, the downstream, is going to be a mixture of water and solid, right? So one easier way is to see actually how much solid content that you have in this, because there's a lots of study done on that. So we can use some of those knowledge, and you can have a water flow, mud flow, and flow slide, and then you can have a slumping. And as you can see that the higher the solid content, the more solid content, your nature of the flow of that material will change, and that will dictate what kind of modeling you will do. So another representation of that whole thing is just by this plot. It's basically saying the same thing. We're showing like a range of material, like starting from iron tailings to a coal tailings, which is the heaviest to the lightest, and then the line in the middle is more like the average. As you can see that at the lower end, it's a sediment concentration is low, so it's a water flood, and then mud flood, like in the next stage, you have more solid content, and then even thicker solid, and then finally, like it will be just mud and debris flow. So this distinction are not precise, but you can use it as a guide. I think that's kind of the idea, and then you have to use your best judgment and available information. And as I said, that it's what need to be done, not how. So that you have some liberty to use your best judgment to come up with how you are going to tackle your given facility. So the one other thing I wanted to highlight as well, how do you model this runout process, right? So we, I think, excuse me, we propose that you can, for the modeling purposes, you can assume it as a two process, not so much two phase. We are just saying two process that could happen in a given facility. Breach. So just for the modeling purposes, so these whole processes can occur simultaneously. One might be followed by the other. There might be very little lag, no lag at all. But I think it's probably conceivable to assume that, yeah, if you have this red line I'm showing, let's say you lost the dam, right? So your pond is very close. It's obvious that the pond material will come out right away. And then once that part is released, then definitely my second process is the material that was retained by this dam will come out depending on their liquefaction and their flow potential. right? So what we are suggesting is that you assume that as a two-process flow, and then use that to do your runout. So you may have to combine this process and do your runout model, but it will depend, on the facility. So that's why things get a little bit more complicated. But there is no one way of doing that. And then also some guidance around, material in the flow runout process and flow type for each of these cases, right? So if you will have an understanding of what material in this row, material in the flow, and then how many processes you are expecting, right? If it is a case 1A, both processes are going to occur, and then case 1B, both processes are going to occur. But I think if you're in case 2A, because you don't have any uh, available water that can actually initiate the process, it will be basically you lose the dam, and then the material behind is going to come out. So it's a phase 2 flow. So phase 2, sorry, the process 2, my mistake. Process 2 is a mud flow, flow slide, or slumping failure, or flow slide. And you will see that we are throwing this item heavily loaded terms like Newtonian, non-Newtonian. These are more hydrotechnical, characterizing the outflow. So that will dictate, what kind of modeling you will be doing. So there are some additional guidance on that in the bulletin. So I'm not going to go too much detail around that. All right. So the last few slides I have is basically the some additional requirement that are also be looked at. So we know that this process is so complex and it's so difficult to get a very accurate estimate of a lot of these parameters and processes. There will be lots of uncertainty, right? So even starting with failure mode, and then the volume of mobilized tailings, interaction between fluids and trailings, properties of the material in the breach outflow, erosion of the dam rate. So, I mean, there is a list of items that are that could pose the uncertainty. Now, even after you get your head around that, you will have to do a almost like a parametric study, because for example, there is an example here, like your breach development, how long it's going to take for the breach to develop, how the side slope is going to do, like the conventional way of doing the inundation study. So those kind of steps are also prevalent for tailings dam, and need to be looked at. All right, so that's all about the study. And then again, now the last few slides is that, okay, now you do the study. What do you do with that? The main purpose of this is, as I said, that emergency preparedness planning and dam failure consequence hazard risk management or environmental impacts assessment. This is just I picked up from a project, and I kind of blocked all the particular information, but it's just going to show you, how you are going to demonstrate your runout, right? So there was a facility, it breached, and then it's going to inundate the downstream assets, and then and then this color coding is giving the magnitude of, what's the volume, sorry, the thickness of the material, or maybe the velocity. That would be different parameters, but that's how these informations are presented after the study is done, and then in a way that it's being useful. The map content, we talked about that as well. What kind of information you need to provide into the map, flood extent, and then frontal and peak flow depths, and all sorts of flood information. This is a simple example of that Maris Pruitt case, that this on the left side is showing the surveyed failure, like this is a tailings pond, and that's where it breached, and then this is the downstream, and then this is being modeled. So you can see that there is a similarity between these outflows. So that's kind of the intent of this sort of study. So before this happens, you can study and you can understand the flood information, so that you can use that information for your subsequent emergency planning or impact assessment or subsequent studies. And then I think there are other ways of providing this information in a meaningful way. I wouldn't be going too much into that, but we can talk about that. And finally, what do you need into the report? I think once you do all this work, you have to prepare a report, and we provide some guidance on that, what such report should include. All right, so path forward. So we published the English version, and the French version is done. I think it just the last bit is going to the publisher in a week or two. So the French version, those of you guys are French spoken, is going to be available probably within a month or two. And then we are also started the Spanish version translation of this document. We know that there are some demand from the Spanish-speaking people on the Southern America. So we'll be preparing a Spanish version. There's no timeline yet, but it's being sanctioned. And then finally, I think the working group is actually also started working to do a training course, because now we got the bulletin and we want to develop a training course so that we can also clarify and elaborate some of these items with the real, with more like, typical examples or case studies, and that way help the practitioners to become more trained and do this type of study. And I also want to mention that if you guys wanted to get additional resources, there is one recent paper by Nahian et al. I think they used the same framework and they looked into a lot of case studies, and you can see some use of that. And then I also came across this other paper, Hussein et al. In 2020. They also talked about extensively about dam breach and then make reference to these approaches. And finally, the CAN breach is a research project. I think they are also working around that. You guys can get in and look into that when you get a chance. Thank you.
Thank you so much for the informative presentation, Mahamood. And thank you for sharing the updated bulletin and guidelines for the Tailings Dam Breach Analysis. We already have one detailed question from Natalia in the chat box. She wants to ask something related to whether, it's a quite detailed question, Natalia. Maybe you can unmute yourself and directly ask your questions to Mahamood.
Hi, everyone. Hi, Mohammad. Can you hear me?
Yeah, I can hear you loud and clear.
Thank you. Thank you for the presentation. It was very nice to hear from you. And so I work a lot with dam breach studies, and I already used the CDA guidelines. So I have a question for you. So in a recent failure in Brazil, it's about 15 days ago, we had a waste pile. It was made from a filter press and I stacked tailings. And then this thing failed and overtopped a downstream dam that was used to retain sediments from the mine area. So my question is, from the CDA perspective, should we consider this kind of scenario, for example, a cascade scenario like that in our study? Because sometimes it's hard to estimate the volume release from this kind of failure, but it will mandate and affect if the dam downstream will overtop or not. So it's kind of a question regarding this.
Yeah, so I think the short answer is, Natalia, is that, if there is a scenario, you have, multiple dams in a row and one dam can fail into the another dam, as you mentioned, the cascading failure. So that has to be definitely looked at, right? So if you have a facility in the one at the very low end of that will likely receive the most of the material that is coming from the upstream, right? So that's why I say that in the one of the slide that you have to look at all possible breach locations, including the cascading breach location. So what I do in my practice and a lot of my colleagues do is that you have to start with a big map of your tailings facility at the very early on, right? And then look into your landscape and then see what are the possible ways that a given dam can fail, right? So if you do that kind of review at the beginning, I would say that you would be capture any cascading scenarios. And then that cascading scenario for the dam at the very end is going to, that is going to be constituting the failure, right? So the short answer is yes. I think if you use CDA guideline, I think it might fall into one of the cases, but that will depend on what material is coming out, right? You will have a water, you will have tailings, so it's your case 1A, right? But in terms of how it's going to breach and all the details that you have to come up, you have to look into those and you have to study those and you have to build those into your study.
Thank you for the question. I have just another question if nobody else wants to ask you something else.
Yeah, you can go ahead, Natalia.
So it's, I have been looking for some rheological data as well. And so it's a question for what CDA recommend for the rheological parameters. So should we use a rotational or oscillatory rheometer for that case?
That's a good question. I think I'm not an expert on that. We have few people on the working group, I think, who is more, who has done this type of test. So I will have to refer you to them. I think unfortunately none of them are likely here today. So yeah, send me that question and then I'll talk to them and then likely I can follow up with you.
Thank you a lot for the answers and for the presentation.
Okay.
Great. There is another question from Hongwei Xia. I think it's your colleagues in Tetra Tech. He wants to know, there are several commercial modeling tools available for dam breach analysis, and which one is more suitable for modeling the fluid tailings flow?
Yeah, so that's a question. I think there is no easy answer because these days there are more than one commercially available packages available. So again, I think it will depend on how you articulate your given case, right? And if you do the initial stages and you kind of figure out that this is what I'm going to expect, like, am I going to expect the low solid content material, which can be modeled as a Newtonian fluid, then any software, any packages that does the Newtonian modeling, you can use. You can use, sometimes we see people use more than one packages and compare them just to be more confident on the outcome because it's a numerical analysis, right? But then if you see that you are dealing with a higher solid content material, then you have to get into that realm of Newtonian or non-Newtonian. So you can do both and you can compare and see what's the effect of non-Newtonian flow and which one is actually more reasonable in terms of your understanding of how this dam is going to, because every time you do an inundation study and you come up with an inundation plan, you have to critique that and understand with respect to your expected inundations and all the values and everything has to make sense. And then if you are dealing with very high solid content, you are not really considering like a large scale flow, then what I use the term geomechanical model, right? So there are some modeling for that. We did talk about those in the bulletin, because if you are dealing with a more confined outflow, right? If you have a relatively high solid content material and it's going to breach and just, you know, inundate the downstream area of the tow in a confined way, then some of those fluid flow model may not be the accurate one. So that needs some experience, and that's how it has to be looked at. There is no simple answer that, okay, this is your case and you go and use this software or that software. So that needs some experience and understanding and judgment.
Thank you so much for the detailed answer. I guess that's the reason you're preparing a trading course for that. And
yeah.
And there is another question from Adolfo. forgive me if I pronounce your name not correctly. He is asking, in the figure, you show the types of flow ordered to the slide. It was good to know the bias considered for more than one solid. Is this figure elaborated considering 3 different materials or more than that?
I'm not sure which are you talking about. I think likely this
The types
figure?
of flow, the types of flows.
Types of flow. Yeah, so this one would be the types of flow figure, or this one. So I think if the question is, are you considering more than one flow? Yeah, there isn't any easy answer to that, because we are not saying that, as I said, that in the process 1 and process 2, it's a tools to understand, give you a tools to estimate your total outflow volume. Now, once you do that processes and separate that, and you come up with your total volume, then I think you shouldn't be hung up with that, process 1, process 2, or types of flow. Then you need to see that, because in reality, all this material will be mixed up and come out, right? It's not that, unless there is a geometric constraint within the downstream or within the tailings facility, and then based on the case history, we know that as soon as the dam fails, your containment is gone, everything will come out, right? So this is my opinion, but I mean, my working group members may or may not agree, but that's kind of the beauty of this thing. Then you will likely have to look into the overall solid content of your material, and then you have to likely model, like, one phase flow. So that could be one way to look at it.
Great. There was another comment. I think it's a comment from Mauro Jr. I think he is answering questions to Natalia. I think in these scenarios involving the failure of the stockpile, you would probably need to estimate the volume using a 3D stability analysis of the pile and use that information on the dam break. Yeah, that's all of the questions from the chat box. We have a lot of experts in the oil sands tailings, especially Dr. Wilson and Dr. Bell in the audience. Maybe there are any questions from the experts in these areas?
Don't put them on the spot.
Yeah, for anyone else, if you have any questions,
it's Ward here. I was trying to find the right button to get. Okay. That was an outstanding presentation. Thank you very much for that.
Thank you.
And I guess our interest, we've been engaged in some of these failures, as you may know. Yeah. I understand the principles of all that you articulated, but I might just point out some of the challenges of trying to sort of predict the size of how the failure will occur. And if you look at Mount Poly, Mount Poly, and you pointed out that's a ring dike, right? There was a lot of dike there.
Yes.
But the failure that occurred was in the breach was only about 200 meters.
That's right.
And as you well know, it was a slump, and then it was overtopped, and then the pond released, and then the tailings eroded out. The erosion opened up the breach, right? So there was a long lag, if you like, time for that failure to occur. It was very complex. It's one of and the other thing I'll just say about Poly is you've got, how do you decide on the risk when nobody seems to think about the length of the embankment, the berm. I mean, it's several kilometers there, and you can see it was where is it going to fail and how much will fail compared to, for example, Fijao, the whole dam, 10 seconds.
Dam. Yeah.
It all released in 10 seconds, the whole dam. So some of these things are so complex, even just trying to decide how might the breach develop and where it might be. And then if you can get that, then you can do the model. But some of these are so complex, but I know you appreciate that. Go ahead, please.
Oh, totally. I think what I'm saying that, when you talk about dam breach, in many cases, people get focused on, okay, what's, I mean, we all see these, big failure, scar and, inundated, rivers and houses. So I think we get fixated on we thought that that's the part we need to model. But as you say that, if you are given a big tailings pond like this Mount Poly I'm just showing, how do you know where it's going to fail and why do you model that, right?
Yeah.
So I'm just throwing this random arrow, like just say that it could fail anywhere, right?
Yeah.
On a given day, given condition. So you are right. So this is a challenging part for a tailings facility. So where we like to challenge the dam owner is that you have to look into the your design and your construction, your foundation, your tailings characteristics, and you have to have have to do a adequate study to understand that where you feel you have the most vulnerable in your dam.
Yeah.
So you would likely know that, like in some cases, but other cases you may not. Like for Mount Poly, definitely they didn't know that there is a lacustrine clay, so that's out of the blue. But then other cases, like if you have upstream dam, you have a lot of tailings, it's likely relatively easier, but for a complex dam like that, you don't know that. So that's a challenge, no doubt, I think, but we cannot underestimate that. But that's I think a useful step that before you undertake even your dam breach, like you can just randomly breach and come up with a model, but that has no value because it will breach in another location, right? So yeah. So yeah, I mean,
yeah, I know
that's one side.
I didn't mean to challenge you. I'm just saying that you're, even if you could know where the failure will occur, how long, how wide, and so forth, that's
another challenge. Yes.
Yeah, that's another challenge. That's all you might know. Just while I'm here, Natalia asked you a very good question. Her whole thesis, she did her master's on the flow from Fundau, and so she's up here now doing her PhD. So she's very interested in what you're presenting. So thank you.
Yeah, no, that's good. Thank you. Yeah, I like to tell people that you can think it like a three bubble, right? So all of this bubble has its own challenge, right? You need to understand what you are holding and how it's going to unfold. And then you need to understand where it's going to fail, and if it fails, how it's going to fail, right? And then once you figure out that, then you have to look into that. Yeah. So I can't separate them as a three separate process, but these whole things need to be looked at, and that's why I think the biggest challenge is.
Okay.
All right.
Well, that was outstanding. We really appreciate the time you've given our group this afternoon. It's been most important. So I'm sorry, I'm thanking you. I'll leave that to our chair.
Okay, no, I appreciate the opportunity.
Thank you so much for the insightful questions, Dr. Wilson. Thank you for the excellent answer, Mahamood. And there is one more question before we call the end to the presentation and session today. And it's from WOM. It's about the monitoring for the data breach. It's about from a practical perspective, do you think any geophysical tools such as LiDAR or ground penetration radar can be used to detect the clues before immense tailing breaches, much like one would try to predict the geohazard vulnerability?
Yeah, I think, I have seen some of the, advanced uses of geophysical methods. I would always encourage personally, for a given facility, if you can work with the geophysical people, and every tailings dam is different, right? As Ward was saying that its setup is unique, its material, its operation, its construction, there will be some unique features, right? So it's hard to say that you just pick one, you just go with LiDAR or you just go with GPR and you can come up with a solution, right? But then it has to be looked into with respect to the given facility and what is the anticipated concern for that. Like, for example, if you think the foundation is the area where you need to monitor, or you think your dam constructed has some weakness, that's what you need to monitor. Or you think that your overall water management the facility is something that you need to monitor, which could lead to the failure, then I think you should tie in and see what technology you can use. And LiDAR or that kind of information is always very useful, I would say, that for this kind of facility, because if you do the LiDAR, like I was engineer of record for a site and we did LiDAR on a bi-yearly basis. And every time we compare, we can see whether there is anything going on that needs some attention, right? So you can see the value outright there. So yes, on a case-by-case basis, if you can capture the site-specific features, then geophysical method has a huge future, I would say, to help us monitor some of these events or the facilities.
Great. Okay, thank you so much for your time, Mahamood, and thank you so much for the great presentation. And we will have these recordings uploaded on the YouTube channel. It's such an informative presentation. It's hard to grasp everything in just an hour. You're more than welcome to visit our YouTube channel. And thank you so much for everyone's time. And
thank you.
Yeah, wish everyone have a good afternoon.